Hello, thank you for joining me. So in this video, we're going to focus on setting up SerratedJQ in a Visual Studio project. Now the way this is going to work is we're going to have an MVC host, a traditional ASP.NET MVC application, and just like it would serve JavaScript files or CSS files or images as static files, it will serve the WebAssembly as a static file. So the WebAssembly itself doesn't require any server-side hosting other than the ability for the browser to download the file because it's only once it's in the browser that it executes. Alongside that, the MVC application can still serve its own HTML files and expose Web API endpoints. These Web API endpoints can actually be connected to via the WebAssembly. So we can have your traditional .NET HTTP clients making calls to Web API endpoints to get JSON models back, and then maybe they transform those models into HTML client side. They might call the MVC partial views and get snippets or fragments of HTML back and use those to insert into the DOM. We'll have interop going through the SerratedJQ library, which talks through the JavaScript interop layer to modify the HTML DOM. We'll be able to subscribe to events such as click events and receive those back in C# event handlers. And those handlers could in turn modify the DOM in response to that. So we really have all the key elements we need to create, a highly interactive application to be able to read the DOM, interact with the DOM, subscribe to events, and retrieve data that might drive the structure of our page if we're doing kind of a model backing view model style client-side UI logic. In the dev environment, we're going to run the MVC server and the bootstrap.dev server as separate self-hosted instances. And the reason we're doing that is we won't debugger support. So as this WebAssembly is running in the browser, it's going to communicate back to the dev server, line number information, basic debugging information about where the execution is at. We'll be able to set breakpoints from Visual Studio in the C# code and have the browser pause at those breakpoints and be able to step through code and inspect variables. So that's really important to be able to iterate quickly through development, is having that debugging experience. Our other files will be served from the MVC server. Our HTML page will reference the Bootstrap file that downloads the WebAssembly and initializes that. So Bootstrap, during compilation, will compile our C# code down to the WebAssembly format, but it also provides some JavaScript files such as the embedded.js that we call from our page to handle all that loading for us. So there's a fairly involved process that involves loading the .NET framework and loading the WebAssembly. And although it's fast, there's a lot of code that supports that. So let's get into it here. So I'm on the SerratedJQ page. I'm just going to go down, and I'll mention the Getting Started project here follows the structure that we're going to go through here. So if you want something that matches kind of your end state that will be working, then that Getting Started project kind of matches where we'll get to at the end of this video. I'm going to go down to installation and the quick start guide. So the first thing we want to do, I always like to start with a blank solution just to get my folder naming set up properly. I don't necessarily want the solution folder to be named the same as the project. We'll just call this tutorial. All right, and then let's add a project. And we're going to do a console application. This is going to become our WebAssembly. So we're going to name this WASM client. So I want to emphasize this is client code. It's just like JavaScript code in that it will be downloaded to the browser. And even though it's in some ways obfuscated, you should just assume that any code, any proprietary information that's in there is going to be exposed to the user if they were savvy enough and persistent enough. So this is client code. Don't put anything in there that you wouldn't put in JavaScript code, for example. Simple to understand. Now we're going to add our MVC application. So I'm going to do a traditional MVC project here. So I'm looking for that one with parentheses model view controller and ASP.NET Core. And the current versions of SerratedJQ do require .NET 8. So we'll name this tutorial.mvc. Just take the defaults. Let's close that. And then we're going to need later, we're going to need a class library. This is going to act as a place to share code between, so you might have some constants or certain declarations, especially when you're doing API integration between the WebAssembly and the MVC Web API endpoints, and you're passing JSON models back and forth. It's good to have a place to put those POCOs, those simple classes that represent those JSON models, and have them referenced from both your MVC and your WASM client application, so that you don't have to duplicate that work, which is really great to just be able to use that same approach from both sides as far as using those C# models. Let's call this WASM shared because, again, I want to emphasize that it's going to be compiled into the WebAssembly. And so any code that a developer might put here is getting shared with the client. So we're going to close this for now. The next thing is we need to drop this code into our, I do want to build the MVC project first just because that initializes some folders in it. And then we're going to jump over to our WASM client into the project file and drop. So this is all of our NuGet references. So we require newtonsoft.json because there's some serialization that goes on with events that we need that for. Bootstrap is the tool that actually compiles our project into the WebAssembly format because it's not a .NET WebAssembly per se, or it's not a .NET assembly per se. It's a special WebAssembly standard format that's compatible with the browser. This is our self-hosted server that communicates that debug information. And this is the SerratedJQ, the jQuery wrapper. So you could omit this if you're not interested in that and you're just trying to get set up with WebAssembly integrated with an MVC application. Now I'll say that the way I'm doing this isn't the typical way that a lot of people use Bootstrap because they're building single page applications. They wouldn't have an MVC backend with separate pages because they're not really generating HTML from the server side. They're doing single page applications. So what we're doing here is a little bit different than what a lot of people would traditionally do with Uno Bootstrap. All right, so adding these references, especially this guy right here, triggers a project reload. I always, before you hit this, you want to make sure you do save all because reloading can lose changes and you can get yourself in a loop where you're trying to make these changes and you keep losing them. So let's go. So we want to make notes. So we should have now a launch settings file. I'm just going to pin this, and we want to disable launching the browser from the WASM server so that we only get a browser launch from the MVC server. And then we're going to make a note of this URL. And let's see, next step is we're going to drill into our view layout. And actually only want this because the other is just kind of a reference point for where to put this. So this needs to come, because we're using SerratedJQ, we're dependent on jQuery being loaded first. So we need the JavaScript library loaded before we load our wrapper. And we want to grab, I'm going to pin this, we want to grab the HTTPS base URL here from the WASM client. Because again, we're loading, this is going to be in the browser that's served by the MVC application. But from that page, we're just going to, think of like if you were to load a JavaScript resource from a CDN or some other location, we're loading our WebAssembly package from the other host. Once you were to deploy this to production, you can move the WebAssembly package into the same project as static files and remove this so that it's just a relative reference. But we're doing it this way again because we want to have debugger support. We need that separate dev server to support that. All right, and then Uno Bootstrap provides a splash screen, and this is the element it needs to populate that splash screen. And we're going to go to our WASM client. So we're in the the main entry point of the WASM client. We're going to change this to an async task because when we call into JavaScript, there are some functions that will, through interop, will support jQuery or JavaScript promises, and those will be exposed as tasks, and so we want to be in an async context to be able to await those. Here's some setup code that we're going to add to program main. I'm going to do it after the write line because the nice thing about this is we'll see this in the browser, and that'll be the first thing that confirms for us that yes, our WebAssembly is running in the browser because we'll see that in the browser console. We have some JavaScript declarations that are required for the interop through SerratedJQ. So we've got those, and then the next thing we'll do is once this main method is executed, we know that the browser has successfully loaded and bootstrapped our WebAssembly module, and it is beginning execution. And so then we'll get here and we'll say wait for document ready, just in case the HTML document isn't ready. And so this is actually the jQuery.ready that we're awaiting, and it's passed, that promise is passed back to us as an await. And then once that document is ready, execution will continue. We need, as a workaround, we have to remove this element. There's an element called base, and this is an element that will change the base URL of your project. And what will happen is it will actually, it assumes that embedded.js is hosted in the same location as your application, which would be true for a single page application, but in this case it's not. And so it'll actually mangle all the URLs in our site. And so we need to remove that element, the base element, once it's successfully loaded. So we remove that. And then the next thing we need to do is trigger the splash screen to let it know that we're done loading. What you do is you add some content to that element. And in this case, we're just going to add a hidden div to trigger that. So a couple small workarounds that you kind of need to play nice with the way Uno Bootstrap does things. So we'll save that. We should be able to build the solution now if I haven't made any mistakes, which is very possible. Sometimes some of these videos can be a little bit time consuming just because getting everything lined up perfectly and smoothly can be a little bit difficult. And not stepping over my own words. So we're going to go in and set startup for both the WASM client and the MVC application. The WASM client, I'm going to choose that. We're going to apply. Yes. So now we have the MVC application and the WASM Bootstrap Dev Server. Both are going to spawn their own console self-hosted windows. And I access that from the solution here, just going to configure startup projects. And we can verify here, it shows multiple startup projects. I'm going to start. Should pop up 2 console windows. So there's one, there's the other one. So we can see this is the WASM client. Now, even though this looks like a console window, this isn't our console application. So it's not the program main entry point that was in our console app. This is a completely separate thing. This is an HTTP server just to serve that static content, and also it has the WebSocket listener for the debugger. Our console app is really getting downloaded into the browser now from the MVC host, and if we go and we F12 into the page, we have some superfluous errors here from the Blazor hot reload trying to load and the course configuration not lining up to allow it to load, but that's not a problem. We can ignore that. We have some flags here because we're in debug mode. Uno WASM will output some information here about the bootstrapper. And then once our module is loaded, now we can see that hello world message. So it's actually going and running this inside the browser in the WebAssembly sandbox. So that's a good sign right there. That's a confirmation that we're making progress. So let's stop that. And I'll close this. All right. Yep, we saw the hello world. It's worth noting that it's good to have a file open, such as this file that's in the WebAssembly project, and always do F6 build, just to make sure, because there isn't a project reference from the MVC app, over to the WASM client, because this is not, they're separate deployables, then you don't automatically necessarily always build one when the other is built. There's not a project dependency there. And so there can be cases where you're sitting here and editing code in the WASM client, and then you launch the MVC application. And even though Visual Studio is really good about detecting changes in projects, it's also really good about not building things that it doesn't think needs to be built. And so if you launch that MVC project, it doesn't have a reference to the client, so it may not build it. So it's always good to just go into the MVC client and explicitly build it, or sometimes do just a solution level rebuild, just to be absolutely sure that when you run, you're running with the most current code. All right, so at this point, any page that loads from that MVC client or from the MVC page is going to run this code, regardless of what page we're on, because we put the initializer in layout. So at this point, what we want to do is we want to have some page-specific scripts that run. So you might be on a certain page and you have a button there, and you want to wire up an event handler or interact with the page in some way, and you only want it to run when you're on that particular page. If you were using JavaScript, of course, you'd have separate JavaScript files. With WebAssembly, it would be a little bit cumbersome if we created a separate project for every page where we had a completely separate WebAssembly deployable. So what we'll do is we'll create separate classes with entry points that will be called based on what page we're on. And there's a lot of ways that I've experimented with slicing this up. One thing that you can do is there's some tools that generate enums based on the actions that are exposed by your controllers. You could kind of wire that up to kind of the method I'm going to show here. In this case, I'm just going to hand code an enum. So I'm going to go into the shared class library. I'm just going to reuse that, even though I should rename the file and be lazy. And we have two pages in our MVC application right now, index and privacy. So I've got two enums corresponding to those. I'm going to add a project reference to the WASM shared project here. And then from the client, I'm also going to add it as a shared dependency, WASM shared. So now WASM share is going to get compiled and included in the WebAssembly client when it gets downloaded to the client. And we can share models, things like API models we can put here for JSON serialization, so the MVC web API endpoints can return models declared here. And then an HTTP client in the WASM application could query that endpoint, get back that JSON, and then deserialize it using those same C# models. So really nice working with C# at both ends of those endpoints. So we're going to go to one of our pages. And let's see. We're going to drop this in, and we want to change this to index. And let's control dot. Yes, we want that using. So now this is actually that enum. So we're just avoiding stringly type things because typos are bad and can waste a lot of time chasing things down. And this is the privacy page, so I'm just going to double check index, privacy. And what we're doing here is we're just adding global this. We're adding to global this a property called this of our own choosing, arbitrary name, nothing special about it. And so when this page loads and our WebAssembly runs, it can look for this property to see what page is loaded. So if we jump over to our client, we're going to add some client code here. And we're going to add, so I would put these in separate class files, of course, but we're just going to drop them in here for the sake of getting things done quickly. So these are basically, if you were to think of these, there's like two different page-specific scripts. And you could have other components that call into, other scripts they call into, but this is sort of the entry point for that page. So we're basically saying, go find the global this variable, grab a property called this, parse it out, convert it to that enum. Now we can switch on that enum and call our page-specific scripts. And of course, I could do, I could use attributes or something to make this a little bit smoother so we don't have a switch case here. And we could just call out to those things individually or use something kind of like a locator pattern lots of ways we could slice that. I'm going to rename this index. Alrighty. F6 from our WASM project. Now F5 to launch. All right, index client, privacy client. Great. All right, now let's enable debugging. So I'm actually going to, so I jumped over here. So I mentioned the getting started project kind of has everything. One thing that I noticed in this video that I missed, which always happens, and it's a good reason why I'm making these videos, is great, as I find these things. This was in there. I don't know how I lost it, but we'll get that fixed. So I need to go to properties, launch settings. So I'm in the MVC project. And what I'm basically doing is I'm telling when the MVC browser page loads, I'm telling it to connect the debugger, the browser link debugger, to the WebAssembly client. So I'm actually going to go back to the WebAssembly. So we're in the WebAssembly now. And you can always mouse over these files that are in tab, and they'll tell you that, okay, we're in the WASM client. And so I need to grab that base URL, the HTTPS URL, and I'm in the section here for HTTPS because by default, we're running the browser is connecting to the HTTPS endpoint. And we also verify in the browser when we launched, this was the port number we were connecting to for the MVC application. And so we're going to grab, I've already got that WASM URL in the clipboard. And you'll notice that this also matches this base URL. So WASM server, same thing. So now our debugger is going to connect to and communicate debug information to that WASM dev server. And the other thing I'm going to double check here, so included in that block of code, we pasted into the project. If we are in debug mode, meaning we've got debug selected as the configuration, the Mono Runtime Debugger is enabled, so this is the WebAssembly debugger. The IO linker is disabled. The IO linker is a newer feature of .NET for scenarios like this where you really want to minimize the size of your .NET assembly, and it does a static analysis of code that you call into in .NET Framework, and it throws out basically everything that you don't need. When you're debugging, that would really mangle things and make it where it couldn't figure out where you're at in code. So for debugging, we need to have that disabled. Now, I'll just mention while we're here, browser embedded is just a special mode that tells the Bootstrap to generate that embedded.js. There are other ways of loading WebAssembly through Uno Bootstrap. This one I find is the most straightforward for this scenario. All right, so we're going to F6, and then I think we've got everything we need to do. Actually, we're going to go to the program and F6 again. I'm also going to set a breakpoint. All right, let's F5. All right, loading up. It's going to take a little bit longer this time just because it knows there's a breakpoint and it's getting things synced up. All right, there's our breakpoint. We're going to open the debug console. And a couple things that we notice is one, that it's at a breakpoint in this runtime.NET runtime. And this is just because when we have a breakpoint here, we're pausing execution in the browser. And if we look at the console, we don't see this message yet. And watch what happens when I F10 to step over. Hello world, it's there. Load our declarations, document ready. We're going to hide the splash screen, so we just added that to trigger the hiding the splash screen. We're going to see right here when we step over this and it calls, it does a select on the body and it pins an element to it. As we step over this, we're going to see that show up on the page. So the code is running in the browser. All that's really happening is that browser link is communicating back to Visual Studio all the information like line numbers and file names and things of that nature that tell it where in the code we're executing at. And then in turn, Visual Studio is communicating information about breakpoints to the browser. And the browser understands certain things about WebAssembly in order to facilitate that. And I can even I can mouse over things and actually see the values of things. So I get all the full experience I'm used to. It's just that we're running in the browser. So that pretty much does it. That's all the components of what you need to interact with the DOM. Again, you could omit some of the stuff that's specific to jQuery or to the jQuery wrapper. The only issue is that if you don't have some other facility by itself running WebAssembly in the browser, sometimes isn't that useful if you can't interact with the DOM. So the whole point of SerratedJQ was just a straightforward way to get an API by leveraging the jQuery API, which I know that some people feel it's a little bit antiquated, but it's a pretty expressive API for what it is. And so it was a way for me to quickly get to the point where I could run C# code in the browser and get a really good kind of native C# feeling experience, but still be able to interact with the DOM. So feel free if you have questions or feedback. I'd also love to hear if you think, hey, this is really interesting, even if you think it's not something that you would use in a production scenario. I'd be happy to hear feedback. If you have, I would say post in discussions. If you have something where you're like, okay, here's a specific use case. I've got a simple reproduction project set up that I can share with you of a bug. Feel free to do that as well, because right now it's just me working on this. And I've been working on this for almost 2 years now, and it's a little bit of a passion project for me. And I'm really happy with where it is at this point. So get in there, give it a try. I hope you are excited as I am about WebAssembly and what it's going to offer, full stack web developers in the future. And this is one thing that I thought would be great for someone who doesn't want to transition to maybe you don't feel that Blazor or some of these other SPA platforms are a good fit for your application, but you do want to get C# as an experience that you can use on the UI logic. This is a way to kind of keep your traditional web application architecture, but then use C# instead of JavaScript. So I find this to be something that I'm really excited to be working on, even if it doesn't take off, or I fully expect that maybe in a year or two, Microsoft or someone else is going to come out with something that kind of supersedes this, that kind of fills that gap. But then again, they may be strictly focused on Blazor and kind of just glaze over this kind of niche as far as using C# client side while keeping a traditional web application architecture. So I'll conclude it there, and I thank you for listening to the end. Have a good night or day, wherever you're at.